All right, let's prepare the answer key of test 1 and 2, which is semester test. Car's tire rotates at an initial angular speed of 15 revolutions per second. The driver accelerates. After 6 seconds, the angular speed of the tire will be 30 revolutions per second. What is the tire's average angular acceleration during this time interval? So we are going to calculate the average angular acceleration in radian per second, according to the given, radian per second squared, but the given is revolution per second, so we have to, there are two ways. You can convert both revolution per second to radian per second, or you can get the result as revolution per second squared and then convert revolution per second squared to radian per second in the end. So let's do it this way. So initial angular speed is 15 revolution per second. A final angular speed is 60 revolution per second. Time interval is 6 seconds. First, let's get the average angular acceleration in revolution per second squared, which is omega final minus omega initial divided by delta t. Final is 30, initial is 15, divided by 6, so take this into bracket, which is going to be 15 divided by 6, 30 minus 15 is 15. 15 divided by 6, which is equal to 2.5. So it is equal to 2.5 revolutions per second squared. But we are going to convert this revolution to radian. We know that every one radian is 6.28, every one revolution is 6.28 radian. So we are going to multiply this 2.5 by 2 pi. So 2.5 multiplied by every revolution is 2 pi radian. So by multiplying this, so you are going to get the result in radian per second square. So which means 2 times 2.5, which is 5 pi. 5 pi radian per second squared is the average angular acceleration in radian per second squared. So the answer is B. A cylinder has a mass of 15 kilograms, so mass is 15 kilograms and radius is 0.5 meters, which is r. If the cylinder rotates with an constant angular speed omega about a fixed axis, what is its angular momentum? So moment of inertia is given for the cylinder. We know that angular momentum is calculated by I times omega. So I is given 1 over 2 mr squared multiplied by omega. We are going to calculate what the angular momentum is. 1 over 2, mass of the cylinder is 15, multiplied by radius of the cylinder is 0.5 but squared, multiplied by angular speed 0.2. So 1 over 2 multiplied by 15 multiplied by 0.5 squared multiplied by 0.2, which is equal to 0.375 kilogram times meter squared per second, which is B. Blah 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 is the perpendicular distance from the axis of rotation to a line drawn along the direction of force. It's the definition of the lever arm, or another name, moment arm. There are two horses on a carousel rotating about its center. One horse is on the edge, the other horse is in the middle between the edge and the center. So the horse on the edge moves with a tangential speed of 4 meters per second. The horse in the middle moves with a tangential speed of what? So this is a carousel. And this carousel is a rigid object. It spins with the same constant angular speed for every single point. There are two horses. One horse is in here, so in the edge, and the other one is in the middle. So this is axis of rotation. This is horse 1, first one. This is the horse 2. So horse 1 has a tangential speed which is 4 meters per second. So horse 2 is following a circular path. But because the radius of the circle is half of the radius of the circle of the large one, so if according to tangential speed equation, which is Vt is equal to r times omega, if r gets divided by 2, because in the edge, which is 4, r times omega, but for the horse, which is in the middle, r becomes r over 2. You are going to divide by 2. If you divide right side by 2, you should divide left side by 2 as well. So answer will be in this case 2 meter per second. So answer is 2.2, and you can easily say that as radius is increasing, tangential speed is increasing. If radius doubles, tangential speed doubles for a horse on a carousel. And g, small g in the equation, small g is equal to capital G mass Earth divided by r squared is called universal gravitation constant. No, it is capital G. Gravitational force, it is force F G. Free fall acceleration, yes. And coefficient of friction, mu S. So answer is C. Identify which condition of equilibrium hold for football traveling in the air. So because there is a net force acting on the ball, which is known as gravitational force, if there's a net force, so no equilibrium, no translational equilibrium. But a gravitational force acts at every single point on the on this ball, or for example, if you think ball divided into 2, right side has a force F, left side has a force F. One of them produces a clockwise, counterclockwise torque, the other one produces counterclockwise, equal in magnitude, opposite in direction. Net torque becomes 0 because of the gravitational force. That's why there is only rotational equilibrium, no translational equilibrium. A bicyclist rides along a circular track with an average angular speed of 0.47 radian per second omega average. How long does it take for a cyclist to travel around the 3/4 of the track? So 3.3 over 4 revolution, which is angular displacement. So we know that average angular speed can be calculated by delta theta over delta t. Question about delta t cross product. So delta t is equal to delta theta over omega average. Delta theta is 3 over 4, but this is in revolutions. Every revolution is 6.28 radian divided by omega average, which is equal to 0.47. Let's calculate it. 3 over 4 multiplied by 6.28 divided by 0.47, which is equal to 10, almost, yeah, 10 second. Choice B is the correct answer. An amusement park ride spins riders around a swing attached by cables from the above. What is the most direct cause of the swing centripetal force? So there are two forces acting on a swing when it is moving on a circular path. One force, this is the swing, assume that. One force is the gravitational force. Second one is the tension forced by the cable, Ft. And swing is spinning on a horizontal circle. Ft is perpendicular to the radius, that's why not effective. Ft has a horizontal component of Ft, and force in the cable is the centripetal force. So answer is the force applied by the cable, not gravitational force, not friction force between the swing and the air, because there is no, this friction force is parallel, can never be centripetal force. Normal force by the swing on the rider. No, this is the question about rider, not about this is about the rider, but not about swing. So the force applied by the cable is the answer. Question number 9. A force applied tangentially to a disc of mass of 15 kg and radius is 0.4 meters speeds up the disc with an angular acceleration of 4 radian per second squared. How much is the magnitude of the torque? Magnitude of the magnitude of the force, magnitude of the force. So a force is applied to a tangential to a disc, which is F, or radius of the disc is given. It is equal to 0.4 meters, and accelerates this disc with an alpha. Alpha is equal to 4 radian per second squared. We know that torque is equal to I times alpha, and moment of inertia is given, and torque can be calculated from definition of the torque. Remember, torque is equal to F times T. First, Let's get torque by using the Newton's second law for rotation. I is 1 over 2 mr squared multiplied by alpha. 1 over 2 m is 15, r is 0.4 squared multiplied by alpha, which is 4. When we multiply them, we will calculate the torque acting on the disk. 1 over 2 is 0.5 multiplied by 15 multiplied by 0.4 squared multiplied by 4, which is equal to 4.8. Torque is 4.8 Newton meter. Now we can use definition of the torque from the section 1. So this torque is equal to F times D. D is in here is the radius and the angle between the radius and the force, because tangent force is tangent to the circle 90 degrees, so we don't need to write it because sine 90 is 1. 4.8 is equal to F is the question multiplied by R, distance is radius, which is 0.4, divided by 0.4 divided by 0.4. So F is going to be 4.8 divided by 0.4, which is equal to 12. 12 Newton is the force. Question number 10. A disk of mass 1.5 kilogram mass and the radius r 0.2 meter rolls without slipping on an inclined plane. What is the total kinetic energy of the disk at the instant when the instantaneous speed of the center of mass vt, translational speed 2 meters per second? Remember, we have a hack equation for calculating total kinetic energy, which is we are going to multiply translational kinetic energy by c plus 1. What is c? Coefficient of inertia. C is 1 over 2. So let's do it. 1 over 2 m. M is 1.5. Vt is translational speed, which is instantaneous speed of central mass. 2 squared. C is 0.5, which is 1 over 2 plus 1. So let's do it. 1 over 2 multiplied by 1.5 multiplied by square root of 2 multiplied by 0.5 plus 1, 1.5. Answer is 4.5 joule. 4.5 joule is the answer. A car travels around 628 meter circular track if the magnitude of the force that maintains circular motion is 312 Newton and the tangential speed of the car is 40 meters, find the mass of the car. So we are going to use centrifugal force equation, mvt squared over r, and because mass is the question, get vt squared over r to the left side by flipping. So m is going to be fc multiplied by r over vt squared. Fc is given, vt is given, r is not given. We are going to calculate the r from the circumference, because circumference is given. This is circumference, and arc length for 1 revolution, and we know that circumference is equal to 2 pi r. 628 is equal to 2 pi 6.28 multiplied by r divided by 6.28 divided by 6.28. So r is going to be I think 100 meters. Then calculate now m. Fc multiplied by r. Fc is 3312 multiplied by r, which is 100, divided by vt squared, which is 14 but square. So let's do it. 3312 multiplied by 100 divided by 14 squared, which is equal to 1689.7 and 1690. This is B. In which of the following situations should the object be treated as an extended object? Football traveling in a year. Traveling is generally refers translational motion. That's why a point mass must be treated. Pivot in the wind is rotational motion. So this is the answer. Moon orbiting the Earth, translational motion again. Circular motion is a translational motion, remember. Able dropped. Dropped is also referring to translational motion. B is the correct answer for extended object. Give an example of the situation in which an automobile driver can have both centripetal acceleration and tangential acceleration. Centripetal acceleration direction must change on a circle. Tangential acceleration object must speed up or slow down. So let's check. A car driving in a circle with changing tangential speed. A drive in a circle, causes a centripetal acceleration. Changing tangential speed also causes a tangential. One of them is AC, the other one is 80. This is correct one. A car moving a straight line path, never. A car driving in a circle at constant speed, in a circle AC but constant speed 80, 0. So this is A is the correct answer. And question number 14, blah 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 is the energy of one object due to its translational motion, which is energy of one object due to translational motion is known as translational kinetic energy. The stick is rotating as it travels through the air. The ends of the stick trace out blah 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 around the center of mass, draws a circle. 19 centimeter screwdriver is used to pry open a can of paint if the extra rotation is 2 meters from the end of the screwdriver blade and the force of 64 newtons is exerted on the end of the screwdriver handle. What force is applied to the lid? So screwdriver is something like this. So its total length is 19 centimeters, and then you are trying to open the lid. This is the lid, and then this is the axis of rotation, O. That distance is given as 2 centimeters. If it is 2 centimeters, that right side must be 17 centimeters. And a force is applied in here 64 Newton. So then, of course, the blade will pushing the lid up with a force Fn, and then there's a reaction force on the blade by equal in magnitude opposite in direction. So we are going to find this force, how much. So this force produces counterclockwise rotation, 64 produces clockwise rotation. Here is the axis of rotation. About this point we can write the net torque is equal to 0, which means torque produced by 64 Newton is, say, that negative 64 multiplied by 0.17. Even you can use centimeter, but better to convert it to meters. 64 multiplied by 0.17, which is equal to negative 11 Newton meter. And the Fn produces the force between the lid and the blade produces a torque which is positive Fn multiplied by 2 centimeter, 0.02. So sum of these two torque must be equal to 0. Then 0.02 Fn must be equal to 11. Divide by 0.02. Divide by 0.02. 11 divided by 0.02, which is equal to 544. This is the correct answer. And at which of the 7 positions indicated in the figure should the supporting pivot be located to produce a net positive torque? First, we should find where the no rotation point, and equilibrium, is provided from which point. We should first get it. Remember, we said we are going to count the number of divisions. There are 1, 2, 3, 4, 5, 6, 7, 8 divisions. So length from one force to another one is 8 divisions. And we are going to support this system from the point which is closer to greater force, but where exactly we don't know. We are going to randomly choose a point. Okay, randomly I'm choosing a point in here. So we are going to say that one side is x, the other side will be 8 minus x, and in here from this point we are going to apply Fn. This point is going to be location of the unknown force, which is the axis of rotation. 90 Newton produces a clockwise, counterclockwise torque. 150 produces a clockwise torque. So let's calculate them. 90 multiplied by x to the axis of rotation, but 150 produces a negative torque. Negative 150 multiplied by 8 minus x. Fn produces 0 torque. Torque n is equal to 0. Add these 4 torques and make them equal to 0, which means 90x plus 0 minus 150, 8 minus x, which must be equal to 0. 90x. So this multiplication is negative 1200. Negative times negative becomes positive. 150x is equal to 0. So when we add them, it becomes 240x is equal to 1200 divided by 240 divided by 240. So no rotation point is 1200 divided by 240. 5 divisions. So let's count 5 divisions. 1, 2, 3, 4, 5, which is E. E is the no rotation point. And the point on the right side of E produces a positive net torque. Positive net torque. The points on the left of the no rotation point produces negative net torque. So then, which points are on the right? F and G. F and G produces a positive net torque, but other points, E produces zero torque, which is no rotation point, and but A, B, C, and D produces negative net torque. Question number 18. The tangential acceleration of a point on the edge of a rotating disk is, with a radius of 0.27 meter, equals to 2 meter per second. VT tangential, pardon, AT tangential acceleration, not VT. Tangential acceleration is 2 meter per second square. Radius is 0.27 meters. Calculate the angular acceleration of a point 0.12 meter away from the center of the disk. Remember, for a rigid object, it's a disk, every point will have the same angular acceleration. Just calculate angular acceleration by the equation AT is equal to R times alpha divided by R divided by R. Alpha is equal to AT divided by R. But we are going to use which R? Of course, at this R, this is the angular tangential acceleration. So 2 over 0.27. So 2 divided by 0.27, which is equal to 7.4. 41 radian per second squared. So this is the correct answer. So for a rotating object to remain rigid as does the bicycle, every portion of the object must have the same angular quantities. So which one is angular? This is not angular. Displacement is an angular quantity. Which of the following represents Newton's second law in circular motion? Circular motion. Newton's second law in circular motion is this one, B. So which of the following represents in circular motion? Fc is equal to m times AC. Which of the following rules is the rule for the translational kinetic energy? 1 over 2 mv squared. The angle through which an object is rotating in a specific direction is called angular displacement. And question number 23. A bicycle wheel turns at a constant angular speed of 25 radian per second, which is omega. When a reflector is at some initial distance from the axle, the total moment of inertia of the wheel and reflector total moment of inertia. So initial moment of inertia of the system I initial angular speed. What is the angular speed of the wheel when the reflector slides away from the axle, and the final moment of inertia of the system becomes 0.20. So in here you don't need to calculate the moment inertia, they are given. Just you are going to use the conservation equation. What is that equation? I final omega final is equal to I initial omega initial. So I final is 0.20, omega final is the question, I initial is 0.18, omega initial is 25. Divide by 0.20, divide by 0.20. So omega final becomes 0.18 multiplied by 25 divided by 0.20, which is equal to 22.5 radian per second squared. B. The approximate magnitude of the gravitational force between two centers of 0.4 kilogram billiard ball and 0.5 kilogram billiard ball is 8.9 times 10 to the power negative 11. The distance between them is what? So we are going to use the equation for gravitational force capital G m1 m2 divided by r squared. R squared is the question. R is the question. R squared is equal to capital G m1 m2 divided by fg. Let's get the square root and calculate r. R is equal to, inside the root bracket, G m1 m2 divided by Fg is the answer. Let's calculate it. So root of the bracket, which is 6.67 times 10 to the power of negative 11 times m1 is 0.4, m2 is 0.5 divided by Fg 8.9 times 10 to the power of negative 11. Always take the denominator into bracket if there is an exponential number, and then always use the bracket inside the root. 6.67 root bracket 6.67 times 10 to the power of negative 11 times 0.4 times 0.5 divided by, again bracket, 8.9 times 10 to the power of negative 11, close the bracket. Once again, close the bracket. Answer is 0.39. 0.39, almost 0.40 meters. So answers, one of the answers must change. An object is in translational equilibrium only if translational equilibrium condition, net force acting on the object must be equal to 0. So only net force acting on the object must be equal to 0. Two objects with two specified mass and the specified distance separates them. If the distance between them changes by a factor of blah blah blah, the distance of the first time, the gravitational force between them changes by 1/16. So gravitational force initially F, and we know that F is proportional to 1/r squared, square of the separation. But in the next one, in the second one, it must change by 1/16, which means we are going to multiply F by 1/16, and then which means F/16 is this. What is F/16? So to make it F/16, the right side also must change by 1/16r squared. So if left side decrease by 9/16, the right side also must decrease by 16. However, question is asking you how many times r changes. That's why you should get the square root and of this one. So square root of 16 times r square must be equal to this number. Square root of 16 is 4 r and then squared, which means distance must change from r to 4r. Yani for the distance increased by a factor of 4. And also we know that if you want to change the decrease the gravitational force, you should increase the distance first and by a watt factor. These two are not correct. This one or that one. If it was F is equal to 1/r, so it would be if the force changes by a factor of if you decrease the force decreases by a factor of 16, r must increase by 16. But because there is the square, you should get the square root of this. So that's why you are going to get the 4. Blah 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 is the resultant effective force on a body that moves in a circular path and directed towards the center of that circular path, which is the definition of centripetal force. A solid disk rolls along a horizontal surface at a constant linear speed without slipping. What is the ratio of the rotational kinetic energy about the center of cylinder to its total kinetic energy? So remember equation, there is an equation we prepared for this. Kinetic energy rotational divided by total is C divided by C plus 1, and C is 0.5. 0.5 divided by, that's right, in ratio number 1/2 divided by 1/2 plus 1. So which is 1/2 divided by, this becomes 3/2. Flip it, 1/2 times 2/3, 2 is going to simplify, 1/3 is the answer. One of the following equations is to calculate the centripetal force. MC is mr omega m omega r, mvt squared over r is the correct answer. What Which translational quantity is equivalent to torque in rotation? So which is force. Force in translation, torque in rotation. A hollow sphere, a solid ring, and a solid disk with the same mass and similar di, all of them start rolling together without slipping on an incline of the specific slope, and then from the same height. Which of the three objects will win the race to the bottom? The one which has a smaller coefficient of inertia. Hollow sphere is 2/3. Solid ring is 1 because mr squared. Solid disk is 1/2. So which one is smallest? 2/3. One is the greatest, so that's why it's the last. Solid disk 1/2 greater or 2/3 greater? So 2/3 is greater than 1/2. 1/2 is smaller. That's why solid disk will win the race. If the angular speed of the object if the angular speed of an object increases, it's tangential acceleration. So if there's an increase in angular, according to tangential acceleration equation, delta omega over delta t, if there's an increase in tangential speed, so tangential acceleration must be positive. So positive. The minimum force that must be exerted at the end of 0.34 meter long range to lose in a knot is 150. What minimum force is required when the force is exerted from the middle of the long range? And initially, you are going to apply a force at the end, which is 150 Newton over a distance of 0.34. So you can start this not rotate. This is the minimum force. That's why the minimum torque. But if you take the force to the middle, 150. Pardon. If you take the force to the middle, which is half of that number, it becomes 0.17 meters. So the force must double to produce the same amount of torque, which must be 300 Newton, because 300 multiplied by 0.17 is equal to 150 multiplied by 0.34, which is minimum torque to start rotation. For an object in a uniform circular motion, which of the following is not directed towards the center of the circular path: tangential velocity and tangential acceleration, centripetal force Fc always towards the center, change in velocity delta V always towards the center, and centripetal acceleration AC always towards the center, but tangential quantities are tangent to the circle, which is perpendicular to radius. A solid ball 240 Newton with a radius of 0.2 meter rolls 6 meter down a ramp. So this is a ramp which is 6 solid balls start from rest 6 meter down like this, 37 degrees. If the balls start from rest at the top of the ramp, what is the instantaneous linear speed of the center of ball at the bottom of the ramp? So in here, calculate the translational speed, but first you should get what h is. H can be calculated by length of the ramp, 6 multiplied by sine 37, so which is equal to 3.6 meters. Then you can use the Heck equation for calculating the tangential translational speed, which is known as instantaneous linear speed of the center of ball mass, root of 2gh divided by c plus 1. So 2 times g times 9.81, h is 3.6 divided by c plus 1. C is, it's a solid ball. Solid ball has a moment of inertia equation 2/5. 2/5 plus 1. So let's use the calculator. 2 multiplied by 9.81. 2 multiplied by 9.81 multiplied by 3.6 divided by 2/5 plus 1, which is 7/2, divided by 7/2, 7/2, and then take the root of this 20, which is equal to 4.5, almost 4.5 meter per second. And here is also we have a problem. 16.7. We should check this answers again. 4.5. Blah 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 is the line perpendicular to the side of the Ferris wheel and passing through the Ferris wheel. It's the axis of rotation of the Ferris wheel. What data do you need to calculate the orbital speed of the planet around the sun? So always you need the mass of the object which is in the center. So planet, this is the star, which is sun. Planets are revolving. You don't need the mass of the revolving object. You need the mass of the object in the center, which is the mass of the sun and the radius of the orbit only. Also, there's a proof about this in the book, which was the one of the question mixture. The angle between the direction of the centripetal acceleration AC and tangential velocity is 90 degrees. All tangential acceleration is tangent to the circle. Centripetal acceleration is on the radius, so angle between them is 90 degrees. How many rotations does the second hand of the complete in 10 seconds? You know that for second hand, one rotation takes 60 seconds. So 10 seconds, how many rotations is the question? X is equal to 10 over 60, which is equal to 1 over 6 rotations. So 1 over 6 is the answer. And question number 40. A 12 kilograms uniform solid cylinder has a diameter of 0.2. So this is the mass, and this is diameter. So radius must be 0.2, half of this value. If the cylinder accelerates at 0.25 radian per second squared, which is alpha, as it rotates about an axis to its center, how large the torque acting on the cylinder? So we can calculate the torque by Newton's second law for rotational motion. Rotation. I is given as 1 over 2 mr squared. Alpha also given. So let's write the number. M is 12, R is 0.2, but squared multiplied by alpha, 0.25. So let's multiply them all times 0.12 squared times 0.25, which is equal to 0.06 Newton meter, which is A. A man weighs 900 Newton, stands on a light board of 3 meter length, 3 meter, and fixed on a 2 support at extremity. So there's a light board, there are 2 supports at extreme points, and the total length is 3 meters. So if the distance between the point where the man stands and the first support is 0.5 meters, what is the force exerted by the second support? Say that this is the second support, this is the first support. The man is 0.5 meter from the first support, somewhere in here. So 0.5 meters. So this man applies a force which is equal to gravitational force. Second support applies Fn. 2 questions about this. Of course, first support also applies Fn1. We are going to choose the location of the unknown force, which is not asked, as extra rotation. Then 900 Newton produces a clockwise torque, but Fn2 produces a counterclockwise torque. This 900 Newton produces a torque which is negative 900 multiplied by distance to x of rotation is the 1.5. So which becomes negative 900 multiplied by 1.5. It's equal to negative 1350 Newton meter. And Fn2 produces a positive torque N2, which is 3 times Fn2. So when we add all these torques, it's going to be equal to 0. 3 times Fn2 minus 1350, because Fn1 is acting at x of rotation, which is torque is 0. So 3 times Fn2 is 1350, divide by 3, divide by 3, divide by 3. Answer is 450. 450 Newton. A solid vertical cylinder with a mass rotates with an angular speed of 7 radian per second, omega, about a fixed vertical axis to its center. A piece of wood is dropped vertically at a point of 0.9 meter from the center of rotation and sticks to the cylinder. So first, angular speed increases, angular momentum decreases, angular momentum increases, moment of inertia increases. First, angular momentum doesn't change because there is no external torque acting on this. This B and C is incorrect. When you add mass to a system, moment of inertia increases. This is correct answer. As moment of inertia increases, this must decrease. Angular speed decreases, so this is the correct answer. On a spinning merry-go-round, a student who is at the point close to the edge of the merry-go-round is walking towards the axis of rotation. The angular speed of the merry-go-round will change. Yes, will change, of course. As it is moving towards the center of the axis of rotation, moment inertia decreases. As moment inertia decreases according to the conservation law, as I decreases, omega must increase because L is constant. So omega, angular speed of the merry-go-round, increases. A car rounds a circular turn with a speed of 65 km per hour. Diameter of the turn is 150 meters, so radius is 60 meters. What is the minimum value of coefficient of static friction between the tires and the road that will allow the car to run current safely? So we will find mu s. Remember mu s, there was an egg equation as well, in a short way. You don't need to do all the steps for the static friction. Force in here is the centripetal force, and we would calculate it like this: AC over G. AC is Vt squared over R divided by G. So let's calculate it. First, you should convert kilometer per hour to meter per second. 60 kilometer per hour multiplied by every kilometer is 1,000 meters, divided by every hour is 3,600. What's the square of this? Divided by RG. R is 60, G is 9.81. Let's do it. 65,000 multiplied by 1,000 divided by 3,600. Square of this value divided by 60 divided by bracket 60 times 9.81, close the bracket. So it's 0.55. So this is the correct answer. A car moving in a circular path with a constant tangential speed. The car is 550 meters far from the center of the circular path. Its centripetal acceleration is 8 meters per second. Calculate tangential speed. So we know that centripetal acceleration is Vt squared over R. So tangential speed cross product, Vt squared is equal to R times AC. So let's calculate Vt squared. R is 50, AC is 8. Vt squared is equal to 400. Get the square root of it is equal to 20 meters per second. The moment of inertia of an object generally depends on object shape, correct. Further axis of rotation is, yes, correct. Mass of the object also correct. All of them is correct. 60 degrees is equal to how many revolutions? We know that one revolution is equal to 360 degrees. So 60 degrees is equal to how many revolutions? Cross product. So x times 360 is equal to 60 times 1, divided by 360, divided by 360, x is equal to 1 over 6, becomes 1 over 6. And a roller coaster car speeds down a hill past point A and then rolls up past point B as shown in the figure. The maximum speed the car can have at point B is 15 meters per second for gravitational force to hold it in track. What is the radius of the track? So which means the gravitational, in here gravitational force is the only centripetal force. So we are going to say that centripetal force is equal to gravitational force. What is the equation for centripetal force? M T squared over R. What is the equation for gravitational force? Mg. Simplify M. So R is the question. R times this cross product first. R times G is equal to Vt squared. Because R is the question, divide by G, divide by G. So R is equal to Vt squared over G. So Vt is 15, squared G is 9.81. Let's calculate it. 15 squared divided by 9.81, which is 23 meters. 23. Yes, one of the answer must be 23. That's to make it D. We can do D. A coin with a diameter of 2.4 centimeters is dropped onto a horizontal surface. The coin starts out with initial angular speed omega initial, rolls in on a straight line without slipping. If the rotation slows in an angular acceleration of the magnitude of 1.2 radian per second square, so alpha is negative because slows 1.6 radian per second square. How many turns does the coin complete before coming to rest? So omega final is 0. So we are going to use the for the kinematic equation. V final squared is equal to V omega initial squared plus 2 alpha delta theta. Final is 0, initial is 22 but squared. 2 times alpha is negative 1.6. Question, what is the angular displacement? First we will calculate it, then how many returns we will find it. So this means 22 squared is 0 is equal to 484 minus 2 times 1.6, 2 times 1.6, which is equal to negative 3.2 delta theta. Negative 3 point, then take this negative 3.2 on the left side as positive. 3.2 delta theta is equal to 484 divided by 3.2 divided by 3.2. So 484 divided by 3.2, which is equal to 151.25 radian. So delta theta in this is the radian. So we are going to divide this radian by 6.28 to get the angular displacement revolution. Divide by 6.28, which is equal to 24 revolutions or turns. In this figure, the 3 forces acting on the wheel have equal magnitudes. All are equal. F. So which force will produce the most torque on the wheel? Because all the distances are the same for the forces. All the angles are important. So the one which acting on 90 degree produces the most torque, which is C. Okay, this is all about the answer key.